All right, in this video, we're going to talk about 3.1, which is the law of sines. We'll get to the law of cosines at a later time, but we'll talk about the law of sines today. All right, so first of all, definition of an oblique triangle. An oblique triangle has no right angles. So they come in two forms, which are obtuse or acute, which I'll show you in a bit. Standard notation for this has capital letters at the angles. So the A in the lower left here, the C up top, and the B in the lower right are all capital, indicating the angles. And the opposite side of those, so the opposite of B would be over here. So we have a B as the length of the side. The opposite of the capital A is a small a, and in this one here, which appears to be the longest one. And the opposite of the C is this bottom one here. All right. We can solve for all of the sides and all of the angles, provided we have certain information. So we either need to have all the sides, or two angles and a side, or two sides and an angle. And we'll go over that right here. So these are the different possibilities. So if we have two angles and then the side in that order, or an angle then a side then an angle, or two sides then an angle, so these first two here, we can use the law of sines to solve for the rest of it. The objective is to, at the end of the problem, have all three angles and all three corresponding opposite sides of those angles. So if we have a situation where we have all three sides, or side angle side, numbers 3 and 4, we would use the law of cosines for that. All right, so this is the law of sines. Again, for the form, acute would have all angles. So if you notice the angle A and angle C and angle B, all of those angles are less than 90 degrees. That's what is defined by an acute triangle. An obtuse triangle has one angle that is above 90 degrees. In this case, it would be A. The angle A is clearly above 90 degrees. All right, so how we solve for the law of sines, essentially what we would have is we would have three pieces of information and we would solve for a fourth. We could have A and then the angle for A, which using sine of A would help us solve, uh, and just B, or just sine of B, or the angle for B, which would help us with sine of B, or we would have one of the C or sine of C's or something along those lines. If you look at the bottom here, you can flip these. Mathematically speaking, there's no difference between A over sine of A equals B over sine of B versus sine of A over A equals sine of B over B. So there's no difference as far as that goes. Now, when solving for these problems, there's three things that can happen. Either there's no triangle that exists, so you're given the information and nothing can work on it. There's exactly one triangle that will exist given given the information that you have, or you could have two distinct triangles that will satisfy the condition. If it's the latter case, this third case, if you are solving a problem and you give me one of the two, and how and what you get will depend upon your, like, what you would do first. I'm satisfied with that. So you don't need to show me both solutions if it has two solutions. Now here's a list of the values of A and A, B, and what would be H would be the height of said triangle, and how many solutions you are going to have. So the first one, where we would have no solutions, is if we have the length of A is less than the length of B in this acute triangle. We'll have no triangles are possible for that. The other way to have no possibilities would be if you're in a situation where your largest angle in an obtuse triangle, so the hypotenuse essentially is, well, less than one of the sides. And that's why this isn't going to work over here. So if you notice A is the hypotenuse, this should be the longest side. It can't be equal to or less than B logically, so you'll have no possibility of that occurring. So these three situations will all produce one. The one that will produce two is if our height, so essentially you have either an acute triangle that goes around like this, or you would have an obtuse triangle that goes like this, both of which would satisfy this sort of dynamic where our height is lower than A, strictly less than A, and A is strictly less than B. So you can see here B would be the hypotenuse of this triangle here of the obtuse, and for the acute, um, this would our B would be bigger as well. And I will do some examples of this in the next video.